Hi everyone, welcome to our YouTube channel, Becoming a ROS Developer here at The Construct. My name is Rodrigo, and what we're going to be doing today is another student presentation. We have with us Thakshila, who created, well, he went through our course of ROS Basics for Python in 5 days. So he's going to show us the project that was required for that course. So hi Thakshila, how are you doing?
Hello, fine. Hello, everyone. So I have completed this cross 5 days course, and it was really interesting, and I got to know many things. So this was my part of my one of my courses. So I found it really interesting, and I have also completed the project, and it was super cool.
Great. So yeah, let's without further ado, just share us with share with us your screen, and you can start showing us what your project does, and then explaining the sections of the project.
Yeah. Okay. Can you all see my screen?
Yes, we can see it.
Okay. Okay. Right. So yeah. So I will first run my code, and let's see whether it works. So I'm going to launch my main launch file, which includes everything and all the services sections and all.
Uh-huh. I think maybe the camera might be frozen. Can you try closing the window and open it again, the camera window? Because it seems like it wasn't spinning.
Yeah. So it looks like
Huh. It looks like there's an issue with the camera feed. So yeah, it looks like it's really laggy. So
Okay.
let me try this. Let me just restart the cameras for a second.
Okay.
Maybe see if it's a memory issue, and I'll be back in a little bit. Although
Okay.
we can kind of see that it's getting a little better.
Okay.
But yes, let me do that. I'll be back in 1 second.
Okay. Fine. Okay. I get plans to talk to David.
All right. How about now? Is it
Yeah, I
better?
can. Yeah, I can see it now.
Great.
So shall I restart the whole thing?
Yeah, yeah.
Okay. So I'll take it manually. Back. Um, it's
It
not coming
seems
back.
like
Shall
it's
I?
still frozen, no?
Actually, I think I can see this scanner. It's spinning.
Yeah, it's
But
spinning, but
yeah, but it's not coming back. Yeah, shall I try this keyboard? I mean,
yeah,
it's
you could try the keyboard. Let's see that.
okay.
That way I'll check if I have to redo the cameras or something. Things are behaving a little strange.
Yeah. Um, yeah, no, it's
Oh, did you see it started moving just now?
right. Okay. Okay. Yeah, I think now it's working.
Okay,
Uh,
so
uh, yeah, I will take it some where like the boards are not detected.
great. Are you setting it in place or something?
Yeah, actually trying to get it some far away from these boards, otherwise they will be detected as a wall.
Okay, I see.
Okay. Um, yeah. So let me run launch the launch this again. Sorry.
All right. Seems like now we're getting
Yeah.
something.
Yeah.
So can you explain us what the robot is doing right now?
Actually, it's looking for the nearest wall. Uh, that it's rotating and it's sensing like it's getting the distance to the nearest wall and rotating it to that and pointing to that side.
Uh-huh.
Uh, then it should now like after a few seconds it should move towards that wall. I think it's again.
So it's do you think it got stuck maybe?
Yeah, it seems like uh,
Hmm. Uh, Maybe we're getting some data.
it's going now.
Oh, there it goes.
Yeah. So now it came to the wall, and then so the it has found the wall and came near to the wall. Now it should like follow the wall.
So now that
I
it's
think.
found the wall and it has aligned itself with it,
Yeah.
it will start following it. Great. Seems like it's kind of rotating a little bit, but
Uh,
now
the
it's
shell, yeah, the shell is not updating. I'm not sure why. Yeah, I mean, like I have printed some messages like the wall is found and the wall following the price,
right.
but it's not. They are not
Maybe
here.
the connection is
Yeah,
strange. So
yeah.
why don't you open a new terminal and, for example, see the hertz of the
Okay,
scan topic. So, for example, like a ROS topic hertz of scan, maybe it's the speed at which we're getting things. Maybe
yeah.
because yeah, it just definitely stopped, but the program hasn't said anything. Do you have a wait for service or something like that?
No, actually, it should. Um,
Something happened because the shell
yeah,
is here.
yeah. It's
We'll try
yeah.
one more. We'll try one more thing, and if not, you can show this to me in the simulation, and I'll
Okay,
investigate
okay,
what's wrong. So just
okay,
disconnect and connect again, and we'll try it again.
okay. Yeah. Um.
Try hit refresh of
Okay.
the
Okay.
page,
Okay.
like the entire
All right. Okay.
website.
Okay.
All right. Okay. I don't try it one more time. Yeah, I don't know what's going on. So why don't you just show me in the simulation then? Because it seems like
Yeah.
we're having some connection issues. So
Yeah.
uh, we'll try it with the simulation.
Okay. So I will start the simulation. Okay, this simulation is loaded, I think. So yeah, so now I will move it to like some other place. Otherwise, when you scan when you detect the distance, these bolts will be detected. So I will take it
Yeah,
far away
make this
from.
a little bigger, yeah, so we can see as well.
Okay. Okay. So now I will run the code. Okay. So
Yes, and while it's doing the
yeah.
program, just explain it to us again.
Okay. Okay. So first, there's a service. That service basically looks for the nearest wall. So then the robot rotates until it point towards the wall, and then it stops. So it should stop in few seconds. Yeah. So now it's found the wall, and now it going forward to the wall until the distance is around like 30 centimeters, and it stops. So the service is now completed. So
Mm-hmm.
then it now basically do the normal wall following thing. So it adjusts its the rotation, and it's uh, go through the wall, and you can see there's action server started at the same time. So the action now gives us the distance the robot has traveled so far. So you can see it's increasing,
Mm-hmm.
and basically I have set a limit to this distance. So after a lap is completed, the robot should stop. Uh, but the thing is now, I think the distance I have set it to the distance in the real robot. So in this one, I think the distances might be like somewhat different. So it might be stopped earlier than I mean before completing one lap.
So it's a lot different, or is it kind of similar?
Um, yeah, it's I think it's somewhat different, like a half of
Half.
the distance. Yeah.
Oh, that's interesting. Because I mean, it's the same space,
Okay.
so it'll do this until what distance do you have it now at? That
Um, yeah, let me check.
Yeah. So now it seems like everything's working. We just have to check that. I mean, you've finalized it. It doesn't matter if it's not a full app, but yeah, if you
Okay.
want, just start showing us how you did each section. Uh,
Okay. Yeah. So first, I have this. I will start with the main file. So this is the main code, and here there are a few functions and some imports. I will explain about them later. But here, if we start from here, now here we
can I ask
subscribe.
you a favor? I'm sorry,
Yeah,
Thakshila. Can
yeah,
you do
yeah.
like a control plus so we can see zoomed in this page, just because it's a little difficult
All right.
to
Yeah,
see
yeah.
through. So if you do control plus, I think you do a zoom in.
Is it visible now?
Yeah. Yeah. Great.
Okay, right. So yeah. So
Perfect.
here now we create a publisher object to the CMD well topic. This is topic we use to like publish the I mean the velocities and angular and linear velocities of the robot, and then we have the record OVM action client. So this action client is made by me. So this is the action client we use to basically get the distance. So it always and it returns the distance uh, as a feedback for every 1 second. I will
Mm-hmm.
go into that, and this is the main node initialization, and this is like we are waiting until the service. So this is a find wall service that we use for like at the initial part where when robot is placed somewhere. This is the service that we use to like rotate it towards facing towards a wall and move towards the wall. So this is that service. So we are waiting until that service is started, and here we initialize the service client. So this is the message used in that find wall uh, service, and it's imported here. So it's a custom made message, and
Mm-hmm.
then yeah, so we call the service from here. So this is the first thing happens. I mean, first thing that's going to happen. So it first, I mean, after running the main code, first thing that we'll do is to call the find all service, and then uh, here it waits until the result, the final result is uh, returned. So the find all service, I will show you the server as well, the find all
Mm-hmm.
service server. So here, what we have mainly done, uh, I have initialized again the command where since the service when we call this service, it rotates the robot and it should move towards the wall. So therefore, we have to publish the velocities, linear and angular velocities, and also we need to get the sensor feedback. So I'm creating a subscriber object from the scan topic. And here we initialize the node, and this is where our service is initialized, service server. And this is the message type is used, and this is the callback function. So whenever this service is called by the name or somewhere else, if this service is called, so it will basically call this function. And
And
in
what do
that
you have
function,
inside that function?
yeah. So in that function, what we do is like we have also initialized another callback for sensor callback that is for this scan topic. So
Mm-hmm.
whenever a scan message is published, so it goes to this sensor callback function. In that, I have created like some variables called current, min, range, and ranges. So they are global, so other functions can access them. And so it gets the ranges, the 720 distances given by the sensor,
Mm-hmm.
and we get the minimum distance. We sort the minimum distance and assign it to the current min range variable. So then that will be used in the service callback function. Uh, I have first set up uh, like like it can be there can be an instance like this now when the service is
Right.
started. We haven't and the sensor feedback is not there yet. So what we can do is until I mean if the sensor is not giving any feedbacks, we are waiting here, and after that we get this current range, and that I'm going to set it to the target as to a variable for target min range, and the task is to like rotate our robot uh, to the direction where I mean to the direction where it has a minimum distance to the wall. So until we reach the top, I mean, until so this is the front sensor, the front, I mean, the sensor value which gives the uh, uh, sensor reading for the front, sensor reading in the front of the robot. So what we do is until that until the front
Yeah, the
sensor,
front of the robot. Yeah.
yeah, it detects. I mean, it gets the target mean value. We rotate it. I think uh, counterclockwise, as I can remember. So, but I mean, exactly we can't get the exact distance. So I have provided some threshold.
Ah, I
So
see.
yeah, if that front sensor getting a value in between target min range minus 0.08 and plus 0.08. So these are some values I have like I got by trial and error. And then until it is in that range, so we rotate our robot. So after
Mm-hmm.
that, this will be facing the wall. And after that, we basically stop the robot by making the velocity 0. And then after 3 seconds, I wait for 3 seconds for safety. And then what we do here, then until the sensor reading is greater than 0.3 meters, I go forward. Then after that, again, after like after uh, going near like 0.3 meters, it stops again the robot. Then I return the true message. So that means basically this is the end of the service.
So that's done.
So
That's how you know the service is done.
yeah, so then I get the result and I basically show it as fine goal service complete.
Okay.
And yeah,
By the way, 5 minutes left.
okay. So then like again I stop the robot and then what you do is like we call to the action client. Uh, sorry, the action server. We call the action server. So in the action server, what happens basically we have this uh, action callback function. In the action callback function, like I initialize a variable called distance and it initializes to 0. So this measures the distance, and I have a infinite loop here, and there's a points array. So this points array is used to store the point 3D object which contains
Right.
x, y, and z uh, values of the robot, the current values,
Uh-huh.
and so they will be stored, they will be appended, and I have set it to 1 second the delay. So therefore, each 1 second this uh, XYZ will be appended to the points array. And this is how I calculate the distance. So it's like basically adding the X and Y distances. So then the D is calculated. So it's added to the total distance. And in this equation, like it basically get the X and Y difference between the previous point and the current point. But at the initial time, there is no previous, I mean, at the first time there's no uh, earlier point, so that will give you error. So in that case I make the distance 0, and after like doing it for so this is where this action will be finished. So I have set the distance to 1.4. So this is obtained by trial and error. So I have like traveled through the path, and a single lap I measured the value. So lap like roughly it gives 1.4. So after this I break this loop, and then until the break, it always provides the feedback. That means each 1 second it gives a feedback message to the main file, so we can see what the current distance is.
Mm-hmm.
And after this point, the loop will be like broken, and then like we get the whole points, and we'll publish it as the result to the main file. So then it will be shown here as the result of the action. And
Right, and that's the last, yeah, state result. Yeah, so you print the all of the points,
yeah,
and that's the end of the program, right?
yeah. And the basic role following is like it's like I get the front, left, and right sensors or sensor values. Uh, and the left sensor is not used. So the front sensor, if it is less than 0.5, that means there's a wall in the front. So I basically rotate it to the left side, and this is when there is a wall. I mean, when there's no wall, like the distance is uh, yeah, it's in the correct frame. So I go forward, and if there is like a wall, the sensor reading of the right sensor variable will be less than 0.2. In that case, I move away from the wall, and if I have moved away from the wall, that means the distance will be greater than 0.3. In that case, I move towards the wall. I rotate towards the wall. So that's the basic role following thing. And
Great.
after everything is completed, after I get the action, I basically like set all the values to zero. The robot basically stops.
Right. And can we see this? Did this happen already in the simulation?
Right. Yeah. Yeah. So it stopped somewhere here. I think we should get the message like, yeah. So lab completed and all the XYZ values are printed.
I see. So basically, if you were to go longer, then you would just set that distance to
Yeah. Yeah.
6 or 7 or whatever.
Yeah. Yeah. Exactly.
Where I'm sorry, I didn't see where you define that distance. That's in
Yeah.
the action client,
Yeah.
or sorry, in the action server.
Yeah.
Oh, I
Essentially.
see. Distance 1.4. Okay, yeah, I
Yeah.
see. Great. Well, nice. Really good job here.
Yeah.
Like
Thank you
Sheila,
very much.
really, really
Yeah.
simple and to the point, and answering the requirements we had. Um,
Yeah.
could you explain again, just one more question that I have, that why you
Okay.
had to have that threshold again? I didn't really quite get that. You had a 8 centimeters or something uh, to in your service server.
Yeah.
You had a threshold there, and I didn't really
Yeah.
quite get it. This
Yeah.
while not ranges, that minus
Yeah.
0 point.
Yeah. Okay. So, like initially, I measure in which direction the car, I mean, the minimum distance is detected from which direction. So that's the target mean
Okay,
range.
so basically the target min range is 30, I think, 30 centimeters, right? 0.3.
Um, no, actually, the thing is now
Oh, the
from the
current. So
the
let's all
current
right.
minimum,
So following that logic, so let's say the current scan, the minimum range is
the minimum range.
I
Yeah.
don't know, at value 110. Then it's gonna
Yeah.
rotate until
Until
that value is at
detect.
360, which is
Yeah.
the
Exactly.
corresponds to the front, and then it'll
Yeah.
start
Yeah.
going forward.
Yeah. Yeah.
But then,
Uh,
if what happened, like my question is, why did you have to add that minus? So you have a 16 centimeter uh, sort of threshold for it to stop. Is there a reason why you had it like that?
Yeah, the thing is now, like when I can I can like basically set this to like exactly equal value
Yeah.
until yeah. But the thing is, when if I do that, and I tried that, but it's not detected since like I'm not sure, but with the design of the robot, when it rotates, the position of the sensor, it's not going to detect the same target value from the front sensor. So there can be like a small difference. So therefore, in order to
Right.
compensate that, I have have a range. I have added a range here.
Okay, okay, I see. And basically you just put 0.8,
Yeah,
0.08 just because like just as a number to have
Yeah,
in there.
exactly. Exactly.
And I guess it'll never go underneath because I'm sorry,
No.
it'll never crash into the wall because it's still uh,
Yeah.
in that range. Okay.
Yeah.
All right. All right. Well, I think other than that, Thakshila, I really understood your
Mm.
project and it worked well. It's a shame that we couldn't have that in the real robo, but that's on our side, so don't worry about that. We'll figure out
Yeah.
what was going on. And yeah, I just wanted you to I just want to congratulate you again. And could you stop sharing your screen so we can
Yeah.
wrap it up here? Looking at ourselves, great. So yes, again, congratulations, Thakshila.
Yeah.
It
Thank you
was a
very much.
nice project and accomplished what we asked for. So, if for everyone else that's watching, if you want to now take a course and finally present what you learned in this course, this is a great way to do it. So, I encourage everyone to take the course and present the project like Thakshila did here. Thank you very much, Thakshila.
Yeah. Thank you very much. See you.
All right, I will see you guys
Okay.
for the next presentation. Bye bye.
Bye.
All right. So great.